People often think that if velocity of an object is large, then the acceleration must also be large. Or they think that if velocity of an object is small, it means that acceleration must be small. Do you think the same way? Stay with me and learn the concepts of acceleration in different scenarios of motion in most easy and interactive way. When you are traveling in a plane with a speed of 800 km per hour or traveling in a car on a smooth straight path, do you feel any pull or push? Your answer would be no. But what about when you are driving a car and press the accelerator to increase the speed, or apply the brake and stop the car suddenly, or turn the car on a turn? You feel a push or pull. When car speed increases, you feel a push against the seat. And when you press the brake, you feel a force in the forward direction. And when the car takes a turn, you feel a push in outward direction of the circular path. The feeling of force is because of sudden change in speed or change in direction of motion. The instantaneous speed with direction known as a velocity. This change in speed or change in direction can be seen as a change in velocity, and the rate of change in velocity is the acceleration. Mathematically, we can write down acceleration as a equal to v2 minus v1 divided by t. Here, v2 and v1 are velocities, the final velocity and initial velocity, and t is the time. More precisely, the time duration in which the velocity changed from v1 to v2. Here, acceleration and velocity both are vector quantities, and the SI unit of measure of acceleration is meter per second square. Now let's consider a few scenarios of a car motion to have a feel of acceleration. A car is traveling in a straight line motion, and the car's speed changes from 0 meter per second to 20 meter per second in 4 seconds. So what is the acceleration of this motion? Acceleration is change in velocity, the rate of change in velocity. So v2 minus v1, so acceleration here is 20 minus 0 divided by the time duration. So this is 5 meter per second square. So acceleration is 5 meter per second square, and as this is a positive value, it means the direction of acceleration is positive direction. Now, if the same change in speed happened in 2 seconds instead of 4 seconds, so acceleration of the car will be 20 minus 0, which is a change in velocity, divided by time. So this becomes 10 meter per second square. Do you see the acceleration has doubled as you reduce the time duration for change to half? So that means the faster the change, the higher the acceleration. Now let's consider the case 3. Here the car speed on higher side. The speed change from 30 meter per second to 50 meter per second in 2 seconds. In this case, the acceleration is 50 minus 30 divided by time, which is again 10 meter per second square. So what you observe here, the speed or velocity is 30 and 50 meter per second, which is higher speeds, while in the case number 2, the velocities are 0 to 20 meter per second. But acceleration is coming 10 meter per second square in both the cases. So that means the acceleration is not the measurement of higher speed, Instead, it is a measure of rate of change in a speed. Faster the change, higher the acceleration. And slower the change means lower the acceleration. So a acceleration doesn't reflect the vehicle's speed. It can be slow or fast. It reflects how fast you're changing the speed. A sudden increase in a speed by pressing the accelerator or sudden drop in speed because of brakes are the example of higher accelerations. Acceleration you can feel, but you don't feel the constant high speed. Now let's get a feel of acceleration of 5 meters per second square in a straight line motion. Let's understand the acceleration from two different perspectives. The first one, when the acceleration is in the direction of motion. The golden arrow here representing the direction of motion, the black arrow presenting the direction of acceleration. So in this case, the direction of motion and acceleration in the same direction, positive x. Let's consider at t equal to 0, the velocity is 0. At t1, t is equal to 1 second, the velocity will be 5 meters per second. You may be thinking how I know it. I know because I know the acceleration in positive x direction, which is same as a motion direction. Here, acceleration of 5 meters per second square means the velocity is changing with 5 meters per second in each second. So when time changes from 0 to 1 second, the velocity changes from 0 to 5 meters per second. Now if I check the velocity at t is equal to 2 seconds, the velocity will be 5 plus 5, 10 meters per second. I think you can predict the velocity as t equal to 3 seconds. Yes, you are right. The velocity is 10 plus 5, 15 meters per second. And so on. So every second increment in time will increase the velocity by 5 meters per second in positive x direction. Now let's check out the another perspective of acceleration. Here the acceleration is in opposite direction, which is minus x direction to the motion. If at t is equal to 0, the velocity is 20 meters per second. At t is equal to 1, in this case the velocity will be 15 meters per second. Why 15? Because in this case the acceleration is opposite to the direction of motion. Because of this opposite direction, the speed of the object will decrease and decrease by the rate of 5 meters per second in each second. So when time changed from 0 to 1 second, the velocity changed from 20 meters per second to 15 meters per second. I think you can predict the velocity at time t is equal to 2 seconds now. Right, now v is 10 meters per second. So during 1 to 2 seconds, for 1 second duration, the velocity further reduced by 5 meters per second. So this type of motion, when your acceleration is opposing your motion, the speed will keep on reducing. Okay, and this type of motion known as deceleration, and deceleration is always related to your decrease in speed or velocity. Now let's take a few scenarios of velocity change in a straight line motion and see what the value of acceleration and its direction in each case. The change in velocity from v1 20 meters per second to v2 40 meters per second in 5 seconds. So acceleration is v2 minus v1 divided by time. So this becomes positive acceleration of 4 meters per second square. The velocities are also positive, that means the car is moving in positive x direction and the acceleration is also positive. So my velocity is increasing with time. Now, see another case where initial velocity is same as in the first case, but the final velocity is 10, which is less than initial velocity. It means the car speed is decreasing. It can happen only when my acceleration is opposite to the direction of my velocity. Let's see acceleration. A is v2 minus v1. So 10 minus 20 divided by 5. So this becomes minus 10 by 5, and that is equal to minus 2 meter per second square. You see, here acceleration is negative, and that is correct because I see the velocity is decreasing with time. So it means my acceleration is opposite to the motion of the car and it causing the reduction in its speed. So car is moving with deceleration of 2 meter per second square in positive x direction. Let's take the case 3. Here change in velocity from v1 20 meter per second to v2 minus 10 meter per second in 5 seconds. Here minus sign showing that your velocity is in negative x direction. So what does that mean? It means initially car was moving in positive direction with 20 meter per second, but after 5 seconds the velocity was in negative x direction with 10 meter per second. How it happened? We'll see it. So here first we see the acceleration. What is acceleration? Acceleration is v2, which is minus 10 minus v1 divided by time. So this means minus 30 by 5, and this is equal to minus 6 meter per second square. It means when car started moving in positive x direction, my acceleration was always minus 6, means in negative direction opposite to the motion of the car. And it reducing the car's speed or velocity in positive x direction by 6 meter per second every second. And because of that, in 5 seconds, my car is stopped going into positive x direction and reached to minus 10 or 10 meter per second in minus x direction. What was happened that initially my car was moving 20 meter per second in positive x direction. Because of negative acceleration, it went and become zero speed or velocity. After, we can calculate how much time it is. After how much time, if you divide 20 by 6, so 6 3 is 18 and divide, so 3.33 seconds. After 3.33 seconds, the velocity was 0. Now since my acceleration is continuously in negative direction, so now car start moving in negative direction. And after another 1.66 seconds, it reaches to 10 meter per second velocity in minus x direction. Okay. Let's check out few other cases. Case number 4, here change in velocity from minus 20 meter per second to minus 40 meter per second. Means both the velocities are in negative direction. That is our first observation. The second observation is that v2 is more in magnitude, means the velocity is increasing in negative direction. It means my acceleration is in negative direction. Okay, let's see what is the value of acceleration and what direction is coming. So acceleration is v2 minus v1. So v2 is minus 40, v1 is minus 20 divided by 5. So this become minus 20 by 5, so minus 4 meter per second square. So that means the car acceleration is 4 meter per second square in minus direction or minus x direction. My velocities are also in negative x direction. That means the car motion and acceleration are in same direction. And that's why my initial velocity is 20. Final velocity is 40 in negative x direction, means the velocity is increasing in negative direction because of negative acceleration, right? Now let's see the case number 5. Here change in velocity from negative 20 meter per second to negative 10 meter per second. So both the cases or both the velocities are in negative direction. That is one thing. So vehicle is moving in negative direction. The other point is my initial velocity was more magnitude wise. Magnitude wise, the final velocity is less as compared to initial velocities. That means car is moving in negative x direction with decreasing speed. And it can happen only if my acceleration is opposite to my motion of the car. Let's see it. So here acceleration is v2 minus v1. v2 is minus 10 minus v1 minus 20 divided by 5, the time duration. So it becomes 10 by 5, so 2 meter per second square positive. So the car acceleration is in positive direction with the magnitude of 2 meter per second square. And that's why the car velocity is decreasing in magnitude in negative x direction. It reduced from 20 to 10. Okay. Now the last case we take here the velocity from negative velocity of 20 meter per second to positive velocity of 10 meter per second. So what is happening here? The velocity in negative direction reducing and getting converted into positive direction. That means I can expect the acceleration in positive direction. Okay. So let's check that. So A equal to V2 minus V1 minus 20. So this will be 30 divided by 5. So it will be plus 6 meter per second square. Right? So I think you might have understood this positive acceleration is basically reducing the velocity in negative direction and then increasing velocity in positive direction. Okay. So that way you can feel the acceleration and you can feel the motion of the vehicle. How it changes with time. How it changes with time in magnitude as well as in direction. Okay. We can measure the acceleration in two different ways. The average acceleration or instantaneous acceleration. Here we have a car motion in a straight line path and representing by VT graph, velocity time graph. In velocity time graph, you see at t is equal to 1 second, the velocity was 5 meter per second, while at t is equal to 3 seconds, the velocity is 35 meter per second. Now if I connect these 2 points, I get a line AB. The slope of this AB line gives me the average acceleration. The slope of this line is nothing but the rise, if I have this rise upon run. So rise is 30 meter per second because 35 minus 5 is your rise and 3 minus 1 is your run. So 30 by 2. So acceleration is 15 meter per second square. And this is nothing but your V2 minus V1 upon time duration. So this is average acceleration. Now if you need to find out the instantaneous acceleration from the same graph, here point T on the graph is correspond to time 2.5 seconds. And if we want to know that instantaneous acceleration of car at 2.5 seconds, we have to draw a tangent to the graph at point T. Something like this. Now the slope of this line PQ, which is a tangent on this graph at point T, gives you the instantaneous acceleration. Here if you see the slope of this line or tangent line is nothing but the rise, which is 45 minus 15 divided by run on time axis, and run is 3 minus 2, which is 1 second. So it's 30 meter per second square. This is the way we can find out the instantaneous acceleration using graph. But we know that the velocity is a function of time. So if we have relation of velocity in respect of t or time, we can always use the calculus. Since the derivative of v with respect to time gives you the acceleration. So dv by dt is your instantaneous acceleration. For example, v is equal to 3t square plus 6t. What is the acceleration? So to find out the acceleration, I need to derive v with respect to time. And this will give you me 6t plus 6. So if I want to know the acceleration at t is equal to 1, that will give me acceleration as 6 into 1 plus 6, so 12 meter per second square. Just I need to put the value of t as an instant of time and I will get the instantaneous acceleration. Now we'll see how we can represent the zero, constant and variable acceleration on VT graph. This is the first graph which represents a horizontal line on VT graph. Since this horizontal line represents a constant velocity, so this graph presents zero acceleration. A is equal to 0 in this case. Okay. Now let's see second graph. Here the velocity of v increasing with time at a constant rate. And this constant rate is nothing but the slope of this line. So here acceleration is constant. Now let's see another situation. Here if you see the velocity changing with time, initially the change in velocity is fast. Slowly if you see per unit change in time, the change in velocity is smaller, right? So initially the acceleration was more and as time passes the acceleration is keep on reducing. This type of acceleration is variable acceleration. So here you can see an example of variable acceleration motion. Here you see at time t is equal to 0, the velocity of the vehicle or any object is 10 meter per second. After 1 second, its velocity is 20 meter per second. So acceleration between these 2 points can be given by 20 minus 10 divided by 1. So 10 meter per second square. The acceleration between point 1 and 2 means time t is equal to 1 second and 2 seconds can be given by the change in velocity, which is 25 minus 20 is 5, and change in time or duration is 1 second, so 5 meter per second square. Now in between 2 and 3 seconds, the acceleration is given by 27 minus 25, which is 2 in 1 second, so 2 meter per second square. So here you see the different acceleration in different interval of time. Acceleration is not constant. This type of accelerations comes into variable acceleration. And that's all we have for today's session. Now it is a time for 3 conceptual questions. Try these questions and put your solution or doubts in comment box. I hope you would have enjoyed this session. If you think you have learned something new today, then please click like button. And subscribe us for similar type of videos. Thank you for watching. See you next time. Bye.